for the relation R defined as A, R, B, if and only if B is divisible by A for all A and B belonging to N, check for reflexivity, symmetry, and transitivity. Let's try to understand. So here we have a relation R which is defined on the set of natural number, meaning R is a subset of the Cartesian product of N with itself. That's what it means when we say R is a relation on the set of natural numbers N. And it's given here that for two numbers A and B, A, R, B, if and only if A, we have B is divisible by A, or in other words, we can say A divides B for all values of A and B belonging to the set of natural number. So this is given to us. Our goal will be to check whether if the relation is reflexive, symmetry, or transitive on the natural number N or not. Okay, so let's start with the first one, reflexivity. Now, how do we check for reflexivity? All we have to do is, let's say for all values, let's say for all values of A belonging to the set of natural number, can we not say that A divides A? Or you can say A divides A. This is always a true statement. A is always going to divide A. For instance, we can say 2. 2 is always going to divide 2. If we take 4, 4 is always going to divide 4. So if A divides A, what does it mean? This simply means that we have a relation A, R, A. Now, if we have A, R, A, now we know for sure that the relation, this simply means A, R, A simply means that when we construct R in terms of a set of ordered pair, so here we are getting A, comma A. If we take some other element B belonging to the set of natural number, then we are going to get B, comma B. This essentially means that for any natural number that we consider, it's always going to divide itself, and so on. So this simply means that A divides A, B divides B, which means that it is true that R is reflexive. This is a reflexive relation. R is reflexive on the set of natural number N. Okay, let's go to the second one. We will now check for symmetry. We'll check for symmetry. Now, to check for symmetry, we're going to consider two elements. Let's say for all A and B belonging to the set of natural number, if A divides B, this does not imply, this does not mean, this does not necessarily mean that B also divides A. We can think in terms of some numbers. So if we are saying that 2 is dividing 4, this does not mean that 4 also divides 2. That's incorrect. So that is why if A divides B, this does not necessarily mean that B divides A. So here what we are saying that A, R, B does not necessarily imply, this implies that B is related to A. So here we can say that R is not a symmetric relation. This is not a symmetric relation on the set of natural numbers. A symmetric relation on N. Okay. Finally, we're going to check for transitivity. So let's check for transitivity. So here we're going to consider three numbers. So let's say those three numbers be A, B, and C. So let A, B, and C, these are all natural numbers. Now, if we say if A divides B and B divides C, then it must be true then A divides C as well. We can understand this with the help of an example. Let's say A equals to 2. Let's say A equals to 2. B equals to 4 and C equals to 8. So here we are saying that 2 divides 4 and we are saying that 4 divides 8. So can we not say that 2 also divides 8? Yeah, that's a true statement. So this simply means that ARB and and then we have BRC. This is implying that we have ARC, which simply means that R is transitive. Relation R is transitive on the set A.